Welcome to Programming News. For August 13, 2026, we're looking at a deep dive post-mortem on a massive database failure caused by a 16-year-old bug, exploring a new movement to make AI training data transparent, and discussing why your AI coding agent might be struggling with what experts call instruction bloat. We start with a cautionary tale for anyone managing distributed systems. Tailscale engineers have released a detailed post-mortem regarding the database corruption incidents that caused significant outages for their service last year. The culprit wasn't a recent code change or a botched deployment, but a deeply buried bug inside SQLite, a head log, a bug that has actually existed since version 3.7.0, dating back over a decade. The issue surfaced during a routine backup pipeline. While Tailscale was uploading snapshots to S3, they began seeing data corruption, even though there were no obvious triggers or changes in the application code itself. Because the bug was so well hidden, standard debugging tools couldn't catch it. Tailscale engineers eventually had to collaborate with the SQLite maintainers to build a custom tool that logs virtual file system activity, which finally allowed them to reproduce the failure in a controlled environment. They identified a rare data race known as the WAL-Reset bug. This happens when a write transaction and a checkpointing process collide while the database is in write-ahead log mode. If a write occurs at a very specific moment during a checkpoint, the system incorrectly assumes certain data pages have been successfully copied from the log to the main database file when they actually haven't. This results in permanent data loss. Crucially, this bug typically only triggers when multiple connections are open and the user deviates from the standard SQLite configuration. In Tailscale's case, their decision to take manual control of the checkpointing process, a move intended to make backups faster, actually created the exact conditions necessary to trigger this rare race condition. It's a stark reminder that even when you're optimizing for performance, deviating from standard library configurations can introduce risks that have been sitting dormant for years. Moving from the layers of local storage to the massive datasets shaping the next generation of intelligence, we're seeing a push for more transparency in how AI models are built. Gregory Kurtzer, the founder of CentOS and Rocky Linux, has launched a new initiative called OpenWALDO. The goal is to move the industry beyond what is currently known as open weight models and toward something much more auditable, fully transparent training datasets. Currently, when a company uses an open weight model, they have access to the model's parameters, but the actual data used to train it remains a black box. OpenWALDO argues that these hidden datasets, which might include copyrighted material, distilled responses from other models, or private user content, create significant risks for the software stacks of the companies building on top of them. There is also the issue of efficiency. Without knowing the data, companies may find themselves wasting massive amounts of compute power on redundant training cycles. OpenWALDO aims to establish a transparent, community-validated baseline of verified data. This would allow developers to build on a common known foundation and then add their own proprietary layers on top. The project has already started with a corpus of about 167 billion reference tokens, including academic papers, government records, and public domain literature. While that is a tiny fraction of the trillions of tokens used by frontier models like GPT-4, the movement is gaining traction as developers look for ways to ensure model safety and provenance through community inspection rather than just top-down certification. Finally, we turn to a more immediate practical concern for developers working with LLMs, the quality of the instructions we give them. Microsoft has released new guidance on what they call instruction hygiene, warning against a growing problem known as instruction bloat. As teams use AI coding agents more heavily, they often find themselves building massive instruction files. These files frequently become cluttered with outdated workarounds, unnecessary style manuals, or what Microsoft calls prompt folklore, phrases like act as a senior engineer that don't actually add technical value. This bloat creates a real performance cost. Every instruction you add consumes part of the model's context window, meaning instructions eventually start competing for attention against the actual code and the specific task at hand. Microsoft also warns of a rules prison effect. This happens when instructions become so restrictive and overly complex that the model loses its autonomy. For example, an agent might become so constrained by rules that it refuses to perform a necessary file edit during a discussion, even when it should be in a read-only review mode. The advice from Microsoft is to treat your instruction files like code. They need regular auditing, pruning, and maintenance. They suggest a subtraction-first approach. Instead of adding a new rule every time an agent makes a mistake, you should only add context after observing a repeatable failure. If a fix is made to the underlying code, the corresponding temporary instruction or workaround should be removed in that same pull request. By treating context like a limited budget and focusing on high-signal information, like non-obvious architectural boundaries or specific build commands, you can keep your AI agents both capable and predictable. Whether it's auditing your SQLite configurations to avoid a decade-old race condition or pruning your LLM prompts to avoid instruction bloat, the theme across these stories is clear: the most critical parts of our stack are often the ones we take for granted.